Hey guys, it's coffee time. No, just kidding. Today I'm going to show you how you can interact with your RedPower computers via physical inputs like levers, redstone and buttons. So let's get started. Grab myself a monitor, CPU, a disk drive, maybe some RAM modules, and the fourth disk. Okay. Note that I'm currently running MineOS version 1.1, so this is the new P5B, I think it is, version of RedPower, and some little things changed from last time I showed you. For example, the erase command is now gone and it is now called forget. So if you have a look in the words list, you won't find the erase command. Now we have the forget word right here. And she added some more disk related reading and writing stuff, but I'm not going to go into detail about those just yet, because I have another task at hand. Ribbon cables, put this one down. Then we need the I/O expander, put this one here, and of course some bundled cable. Bundled cable, there it is. Whoops. Nah. Now, first thing I wanted to do, where is white cable? Okay, and grab myself a lever. Okay, now you see the white cable is now on, but you don't see anything blinking up here, because this I/O extender only shows the outgoing signals and not the incoming signals. So you won't see anything here, so you need to keep an eye out for that. And the thing is, you can do IOX add, loads the currently active state of the bundled cable into the stack, and we can print it out, and it says 1. Because if you know from the last time, the 1 is white cable. If we do, well, where's my, there it is. That stuff away, don't need that anymore. Put down some magenta, some light blue. Oh, I forgot the orange. This way. Okay, some more levers. If I flip the orange one, it should give us the 2, which it indeed does. The magenta one should give us the 4. IOX add dot is 4. And once again, if you combine those, let's say you wanted to have orange and magenta, you would have 2 and 4, which is of course 6. And IOX add dot is now 6. Nice. So now we want to respond to changes on the redstone on our computer. How do we do that? First thing, I need a little bit more space here. And then I need a little bit of redstone. An RS latch will do. And a repeater. Where is this one? Repeater. Ah, there. Okay. Okay. Then a little bit of alloy wire here. And then, last but not least, the button. And it's getting dark again. Nope, I don't want that. Okay. Now what have I done and why have I done it? The thing is, if you want to listen for button changes or button presses, you need an infinite loop to check every so often. So let's say every 2 seconds you would check if the I/O extender now shows that the orange cable is on. And if that's the case, you can output a white signal and reset this RS latch. So, but the thing is, the button only gives a 1 second signal, and if in that time period the computer currently sleeps, it can't recognize that there is a button press. So, and that would not be very good because you just wasted the signal and you can't detect if the button has been pressed or not. And of course you want it to be reliable and not just a random event, and that's why you need the RS latch to hold the button signal as long as the computer hasn't detected it and not resetted it. So now what I can do is, now you see the left side of this RS latch is now on and the right side is off. And if I just do IOX add dot, you see it is 0 because the orange cable is not on. So if I press the button, you see the button went on and it flipped the RS latch to the right side, and this RS latch is now keeping the orange cable on. And if I do the same, IOX add dot, we can see it is 2. And now we can reset the button press via the computer by doing one IOX exclamation. IOX exclamation. Okay. And now you see this light went on. This line turned on and turned the left side back on, and the right side is now off. Now 0 IOX exclamation turns the white cable off again, but the RS latch will keep the signal and the orange line is now completely off again until we press the button. So what we can do now is we can check for the button press. Very simple to do. Write a little program for that. Let's just call it listen. Begin for the infinite loop. Then what we do is we do IOX add to retrieve the currently active cables from the I/O extender. Then we add a 2 to the stack equals if. Basically meaning, if our I/O extender has a value of 2, then do something. And in this case, we just want a simple output. Let's just do carriage return, button pressed, carriage return, then. And again, then is the end statement of the if. And then we could do the reset. Let's just do it here. It's not very efficient this way, but just for the sake of testing. One IOX exclamation, then we wait 5 ticks. 0 IOX exclamation, 5 ticks, and wait another 50 ticks. Again, to close the loop. And if we do listen, our program is now in an infinite loop. And if I press the button, button pressed. If I press it again, button pressed. You see every 3 seconds the reset flips on. Basically, now you have basically the longest time you had to wait until the button press is actually realized by the computer is now 3 seconds, because if you press the button right after the reset, there is the 50 ticks wait here that waits to restart the program. And it's just, if you're on a client machine, it's not really that much of a deal. But if you are running these programs on a server, chances are your server admin might not be happy if you are setting up thousands of computers with endless loops and no tick delays, because they will really lag out the server and you get block lags, and it's in general not really good practice to do that. So that's why I added the delay here. And you can see every time I press the button now, it shows me that I pressed the button. So that works. And now the thing is, I can't exit the program, of course, because I need to press start here on the computer, and then it will break the loop. Because again, it is an infinite loop and there is no conditional statement to break it. So there's nothing you can do except pressing the start button to break the loop. But now this thing I have just programmed is not very safe, and I show you why. Because if you have another button, let's just take the magenta one. I don't know why my Minecraft is so laggy. I guess I'm near a jungle biome, a fairly large jungle biome. Let me just decrease my render distance. But I guess it could be just fraps, I don't know. Oh, okay, no, it's fine. Again, same setup, repeater and the RS ledge here. And then we do the button just here, doesn't matter. Button, where is it? There it is. Okay. Do this one there. So you can activate this circuit for the orange cable. I just do it. Now orange cable is on. And I can also activate this one. Now the magenta one is also on. And the problem you will have now is if you do IOX add dot, you can see we have a 6. And the thing I've just done here is we've done IOX to if, basically checking if the IOX returns a 2. And this is only the case if only the orange cable is active. So basically it doesn't check only for orange, it checks for every cable. And the problem is if you have the magenta and the orange one on, it will not return 2. Thus this if statement would not be true. So there is a thing you need to worry about, and that is this thing I've just written here only works if you have just the orange cable active and nothing else, only the orange one. And if you want that, fine, but I think in most cases you want to check the orange cable itself and ignore the other ones. And there is a fairly simple trick you can do if you understand how to work with binaries. And I'm just going to show you a little bit of this. The thing is, you have the 2 and you have the 4. The 2 is the orange and the 4 is the magenta one. So if you convert those into binary, you will have 0, 0 to 0, 1, 0. So this would be the 2, and 0, 1, 0, 0, this would be the magenta one. Just do a little bit of spacing here. And now you can see the last one here is the 1, 2, 4, 8. So this one gives us, with just the 1 here, at the second position gives us a 2. And this one here gives us a 4. And of course those two combined give us the 6. Okay, so this one, and this is the 6, because we add nothing here, we add a 2 here, and we add a 4 here, gives us the 6. And now we can't just check for the 2 if we want the orange cable, because we have also the 4 active. So what we can do is we take this one, which is the 6. And then we do a logical operation on them, which in this case is a logical AND. We have this available in fourth, the AND. And what that does, it checks every corresponding binary value. So here 0, 0. And it only returns a 1 if both are a 1. So in this case, 0, 0 is 0. 1, 0 is also 0. 1, 1, as I just said, is a 1. And 0, 0 is also 0. So it gives us the second number right here. Okay? And you may ask, now we have a 2. So what? And the thing is, you can either have two things with this, what I've just done here. You can either have two things. You can have the number you wanted, which in this case is a 2, or you can have a 0. Because let's just say you have an 8. Let's just say only the light blue cable is on. Then you would have a binary number like this. And you would want to check for this. And of course, if only light blue is active, you can't have the orange one active. And if you do a logical AND, we have 0, 0, 0, 0, of course. And that says, okay, we have only zeros, meaning the orange cable is not active, because this calculation here with the 1 on the second from the right tells us there is no 1 on the IO extender return, so the orange cable is not active. And I'm writing a little program for that. First, let me define a variable to make my stuff a little bit easier, which is, let me just do the thing once again, variable. Okay, this will make sense in just a second. So now, what we want to do is we want to make a little program that does this stuff for us, that we just need to enter one number of the cable we want to check, and it returns the correct value that we can use for the if. And there's one thing you need to know: the if returns two. Let me just, I think we have a lot of crap in the stack now. Yes, we do. Okay, now it's empty. Okay. The thing you need to know about the if is, let's just do 3 or 4 to equals and print the stack. We get a 0, meaning those are not equal. Okay? Print the stack. If we do 2 equals, what do we get? A -1. So remember that we don't get a 1, we get a -1. Okay, let's get this out of the stack. So what we want our program to do, we want our program to return a 0 to the stack if the cable is not active, and we want it to return a -1 to the stack if the current cable is active. So let's just call the program active. And of course we want to have the value that we check on the stack. So we want to call the program with, let's say, for active if. That's the way we want to call it later on. Now, how do we do that? Of course, the for is in the stack then, when we call the active. And what we want to do is we want to put the IOX value to the stack as well. Oh, wrong way, IOX add. Want to put that to the stack as well. Then we have both of those numbers in the stack, and then we do a logical AND. And this will give us the number, either 0 or a number. And so what we can do is we can now do an if here. 0, equals if, meaning if this is indeed 0, it means there is no, it means that the value that we were expecting is not active. So what we wanted to return to the stack is a 0 as well. Else -1, then. And that should be it. So let's just check the stack. The stack is empty. If we do 2 active, check the stack, we get a -1. Because iox_add, let's just check iox_add, what is currently active? A 6 is currently active. And that is correct. -1 means the 2 is active, because the 2 is indeed active. Because 6 means that the orange and the magenta cable is on, and we checked for the 2, which is the orange cable, and the orange cable is indeed active. Now, if I reset the thing, iox_add, 1 iox exclamation, 0 iox exclamation, iox_add dot, we get a 0, 2 active dot, what do we get? 0, meaning that the orange cable is not currently active. Then we need another program, and let's just erase the old one. Let's just show how you do it now. Forget, listen, semicolon, same syntax, and now we can redefine it. Now the thing I wanted to do, the program. Listen, begin, and then we do 0 active and write it into there. Then we do 2 active if, and then do a little output, carriage return, orange button pressed, carriage return. And if something has been detected, we set the active value to 1. I see why just in a second. 1 active write, then 4 active if, carriage return, magenta button pressed, carriage return, 1 active at, exclamation mark, then, and last but not least, we check if something has been activated by doing active at 1 equals if. And in that case, we reset the thing by doing 1 iox exclamation, 10 ticks, 0 iox exclamation, 10 ticks. Then, in either way, we do 40 ticks to delay this, the circuit, to not lag out any servers. Then again, semicolon, listen. Orange button was pressed and the magenta button was pressed because they were still active from before. If I press the orange button now, it resets the thing and it says the orange button has been pressed. If I press the magenta button, the thing resets and tells me the magenta button has been pressed. And if I am indeed a button spammer and manage to press both buttons at the same time, let me just rewire that. Okay, why not? Okay. Now both were active. And now you can see orange button and magenta button has been pressed. So it detected both of them. And you also see there is no access flashing the bundled cable to reset the thing, because it only sends a reset signal if actually a button press has been detected. And that's why I did the variable here. This only gets a 1 if it is activated here or here when a button press has been detected. So this is pretty much the most efficient way you can listen for button presses, and indeed the most resource not heavy way to do it. And it's also pretty reliable. So this is the code right here. I have my active program which was up there, which checks if the button has been pressed and ignores all the other cables that might or might not be active. So that's it for this tutorial. I hope you liked it, and if you have another suggestion, please leave it in the comments or write me a personal message. I'll hopefully see you next time. Bye bye.